Welcome to the world of Kubernetes, the open-source container orchestration platform that revolutionizes the way we deploy, scale, and manage containerized applications. In this brief overview, we'll explore the fundamental architecture of Kubernetes and its key components. Kubernetes architecture consists of several key components that work together to orchestrate and manage containerized applications. The key components of Kubernetes architecture include the master node, worker node, etcd, and kubelet. Kubernetes operates on a master worker architecture, where there is a central control plane known as the master node and multiple worker nodes responsible for running the actual workloads. This architecture is designed to provide scalability, fault tolerance, and efficient management of containerized applications. Let's explain all component one by one. Master node. The master node is the control plane of the Kubernetes cluster. It's responsible for managing the overall state of the cluster and making global decisions, such as scheduling and scaling applications. The key components on the master node include API server, etcd, controller manager, and scheduler. Let's start with API server. API server serves as the primary management point for the Kubernetes cluster, handling communication with other components. In other words, it exposes the Kubernetes API and serves as the entry point for all administrative tasks and communication within the cluster. etcd, a distributed key-value store that stores the configuration data and the state of the cluster. Next, controller manager. Controller manager ensures that the desired state of the cluster matches the actual state by running controller processes. Controller manager watches the state of the cluster through the API server and makes changes as needed to move the current state closer to the desired state. Next component of master node is scheduler. Scheduler assigns pods to node based on resource availability and other constraints. As applications evolve and demand fluctuates, the scheduler adapts dynamically. It scales your applications by intelligently distributing new pods to nodes with available resources, maintaining an optimal balance within the cluster. Let's move to worker node. Worker nodes are the machines where containers within pods are actually deployed and run. They are responsible for the execution of workloads and report their status back to the master node. In other words, each node is responsible for running containers and communicating with the Kubernetes master to manage the cluster. Key components on a worker node includes kubelet, container runtime, kube proxy, and pod. Let's move to discuss each component role and responsibilities. Kubelet. Kubelet ensures that containers are running in a pod on the node, interacting with the container runtime. Container runtime. Container runtime is the software responsible for running containers, such as Docker or Containerd. Next is kube proxy. Kube proxy maintains network rules on nodes, facilitating communication between pods across the cluster. Let's discuss in detail about the pod. Pod is a logical unit of deployment that encapsulates one or more containers and shared resources. The worker node hosts the pod and runs the containers within it. The kubelet and container runtime collaborate to manage the pod's lifecycle, networking, and storage. Pods are defined in YAML files, specifying the containers, volumes, and other configuration settings. A pod can contain one or more containers that share the same network namespace, storage, and have the ability to communicate with each other using localhost. Let's discuss how it works. First, users or administrators communicate with the Kubernetes system using a tool called kubectl. It's like a universal remote control for managing applications within the Kubernetes environment. Step 2. The API server is the gateway that receives the user's commands. It then collaborates with etcd, a reliable storage system, to record and store the desired state of the cluster. Then Controller Manager continuously watches the cluster state and takes actions to ensure that the actual state matches the desired state. In Step 4, the scheduler, when needed, assigns pods to worker nodes based on the desired state and the availability of resources. Then the kubelet on each worker node ensures that the pods assigned to it are running and healthy by interacting with the container runtime. In summary, the key paradigm of Kubernetes is its declarative model. You provide the state that you want and Kubernetes makes it happen. If you need 5 instances, you don't start 5 separate instances on your own. Instead, you tell Kubernetes that you need 5 instances, and Kubernetes automatically reconciles the state. If something goes wrong with one of your instances and it fails, Kubernetes still knows the state that you want and creates instances on an available node. Kubernetes leverages a master worker architecture to efficiently manage and orchestrate containerized applications. This architecture offering a robust and scalable solution for modern container orchestration. In the upcoming video, we'll delve into the fundamental components of the Kubernetes API. Meanwhile, continue your learning journey.